Hello friends, you can log on to primeaptacademy.com to access complete free video courses. Okay, so this question says that a man at the top of a tower observes that angle of depression of a vehicle at 8 a.m. is 45 degree. Okay, the vehicle is coming towards the tower, so that is why at 8:05 a.m. the angle of depression became 60 degree. Now we need to know at what time will the vehicle reach the bottom of the tower. Okay, assuming that the vehicle is traveling at the constant speed. Okay, so now over here let this be the tower and this is the ground. Let's say the vehicle is here at 8 a.m. Okay, so the man will observe the vehicle like this. Okay, so if the angle of depression is 45 degree, that means this much part is 45 degree. If this is 45 degree, this also has to be 45 degree. Now this is 90 degree. Okay, so this is the tower, this is where the vehicle is. Okay, now this is at 8 a.m. This is at 8 a.m. I'm going to write the time here at 8 a.m. Okay, at 8:05 the car is somewhere here. So now the angle of depression will be this much, which is 60 degree. So now if this is 60 degree, this part has to be 60 degree as well. Okay, because this line and this line is parallel. Okay, so now this is at 8:05 a.m. So this is what the situation is. Okay, so now if you look at it, if we assume the height of the tower to be h, okay, initially when the vehicle is at 8 o'clock, at this point, this right angle triangle, if I draw like this is h, okay, and this is 90 degrees, this is 45 degree. So if this is 45, this is 90, this also has to be 45. Okay, so this is 45, 45, 90. That means this is an isosceles right angle triangle. Okay, not draw it again. So here, this is the height of the tower. This is where the vehicle is. This is 45 degrees. So this is also 45 degree. That means this is isosceles. So if this is h, this much part also should be h. So from here to here to here, it is h. Okay, now so this much part is h. Now this much part, if I take another right angle triangle, which is the right angle triangle at 8:05, the height of the tower will be h. This is 60 degree. Okay, now if you look at it, we know the perpendicular over here for this angle, we need to find the base. So we'll take tan of theta. So tan of 60 degree is this much part. So tan theta is perpendicular upon base. So tan 60 degree is h upon this distance. Let this be d. So this is h upon d. Okay. Tan 60 is root 3. So this is under root 3. So d will be h upon root 3. So we can say distance d is h upon root 3. Okay. Over here, so this much part d is h upon root 3. So this is h over root 3. Okay. So now this much is h over root 3. This whole thing is h. So this much part, the distance the car traveled. Okay. So distance car traveled, distance car or vehicle, whatever it is, distance vehicle traveled, that has to be h minus h upon root 3. Okay, because this is h and this is h by root 3. The car traveled from this point to this point, so it traveled h minus h by root 3. So that is root 3 of h minus h. So root 3 of h times root 3 minus 1 upon root 3. So this is the distance traveled in 5 minutes. Okay, so this is the distance traveled in 5 minutes. Let me rub this off. So this is the distance traveled. Time t is 5 minutes. Okay, because from 8 o'clock the next observation is at 8:05. So it is 5 minutes. So we know speed is distance upon time. Okay, so distance is h times root 3 minus 1 by root 3. Okay, so we took root 3 as the LCM here. So this is root 3h minus h. So we took h common. So that is h times root 3 minus 1 upon root 3. So this is distance divided by time, which is 5. Okay, so we can write this as 5 root 3 here. So this is the speed. Okay, now the remaining distance that the car needs to travel is h upon root 3. Okay, so if we find the time, the new time that we have to find, t dash, from 8:05, time is distance upon speed. Distance to be traveled is h upon root 3. Time, the speed is h times root 3 minus 1 upon 5 root 3. Okay, upon 5 root 3. This is the new time. So h cancels out. Okay, so this will be then 5 root 3 goes up and root 3 will be here. So t dash will be 5 root 3 upon root 3 times root 3 minus 1. Okay, so root 3 cancels out. So this becomes 5 upon root 3 minus 1. T dash is 5 upon under root 3 minus 1. Okay, so it will take these many more minutes. So root 3 value is approximately equal to, root 3 is approximately equal to 1.73. Okay, so 1.73 minus 1, that is 0.73. So t dash is 5 upon 0.73, because that is 1.73 minus 1. So t dash is then approximately equal to 6.8. Okay, so from 8:05 it is going to take 6.8 minutes more. Okay, so from 8:05, 6 minutes more is 8:11, and 0.8 minute is 48 seconds. Okay, so it will arrive at 8:11:48. Okay, where 48 seconds is this. Okay, so this is 8:11 a.m. and 48 seconds. Okay, or if you look at it from the options, it says 48 seconds past 8:11. Okay, because 6.8, if I translate this into minute, time, that will be 6 minutes and 0.8 seconds. So it is 6 minutes and 48 seconds. Okay, so t dash is 6 minutes and 48 seconds. So from 8:05, that will be then equal to 48 seconds past 8:11 a.m. Okay, so this is the approximate time at which the vehicle will arrive at the bottom of the tower. Alright, so this is the correct answer, 48 seconds past 8:11 a.m. Alright, that is how we solve this question.